Okay, so we're back to solving inequalities. This time we're going to have our variables on both sides. So just like if we're solving an equation, you'd want to move your variables to the same side. And because with inequalities, for graphing purposes, it's easier to have it on the left-hand side, we're always going to move from the right to the left. So we may end up with some negative variables, but it's easier to deal with that than having to flip everything around. So on my inequality, I'm going to move the negative 2y. And since it's a negative 2y, I'm going to add 2y to both sides. And so now a 5y and 2y becomes 7y. I have the plus 1, less than, and then this is a negative 6. So don't forget that negative that comes down with it. And then I'm back to the two-step equation. I move the 1. I divide by 7. And I get an inequality of y is less than negative 1. And then don't forget on our number line, we start with our negative 1 and we go up 1, down 1. And then this is an open dot because it's just less than, not less than or equal to. And then we go towards the lower numbers. So on our next one, we're doing the same thing. We're moving our variable from left to right. So if this is a positive 2m, I'm going to subtract 2m on both sides. That's going to cancel that out. So now I have a 2m minus 3 is less than 6. I add 3 to both sides. So now I have a 2m is less than 9. I divide by 2. And m is less than 9 halves. And you can go ahead and take this 9 halves. You could turn it into a decimal if you want to. You could say m is less than 4.5. Doesn't really matter. If you're graphing, you can graph by 0.5s or you can graph by halves. So I can go 9 halves, go up 1 to 10 halves, go down 1 to 8 halves. And we can look at that and realize that 8 halves is really 4. 10 halves is really 5. And that's okay. It doesn't really matter. With our number line, it's a less than symbol, so it does not include that 4.5 or 9 halves. And then with everything less than that, so we go to the left. Okay, so for our next one, we have an x and a 3x, and I like rewriting mine so it says 1x. So that way when I start adding and subtracting, I've got numbers I can work with. And then from here, we're going to move everything, we're going to move my x's to the left-hand side. So I'm going to subtract 3x on both sides. And that's going to give me a negative 2x is greater than or equal to 8. And then I divide by negative 2. And because I'm dividing by that negative number, this symbol is going to have to flip around. So the 2's cancel, negatives give me x. This is now less than or equal to, and 8 divided by negative 2 is negative 4. And so then on our number line, we've got that negative 4, go up 1 to negative 3, down 1 to negative 5. And this is a greater or less than or equal to. And the or equal to means it's a closed dot. Less than means that we want all values to the left or on the lower numbers. So on our next one, we again move our x's to the left-hand side. So I'm minus 7x on both sides. So 4x minus 7x gives me a negative 3x less than or equal to 6. I divide by the negative 3. And because that's negative, this is going to flip around. So x is now greater than or equal to negative 2. And again, negative 2 in the middle, go up 1 to negative 1, down 1 to negative 3. It's a closed dot because of the or equal to. And then because it's greater than, our arrow goes towards the bigger numbers. Okay, so again, just reiterating all that chapter 1 stuff, all the inequality stuff we've been talking about. Okay, so let's look at our next example, getting a little bit more complicated. Now we have our parentheses. So with our parentheses, we're still distributing. So 5 times 2 gives me 10. 5 times a minus y gives me minus 5y. That is greater than or equal to. Now I distribute over here. And that should be a y. I don't know why that's an r. So this is a 3y, and then 3 times minus 2 is minus 6. And now I want to move my y's all to that left-hand side. So So if this is a positive 3y, I would subtract 3y. So that would go away. And now I have a 10, and then a minus 5 and a minus 3 becomes minus 8y. And that is greater than or equal to, and then over here, I've got to bring down that minus 6. So from here, I'm just continuing to solve. So now I have to move the 10 away from my y, so I'm minus 10 on both sides. So now I'm left with a minus 8y, which is really just a negative 8y. That's greater than or equal to negative 16. And now I have to get rid of the negative 8, so I divide by negative 8. And because that's negative, that's going to flip around. So the 8's cancel, the negatives cancel, and I have y is less than or equal to positive 2. Okay, for our next one, again, parentheses. Oh, this time we have the same letter. That's always nice. So we distribute in that negative 4. So negative 4 times 3 is negative 12. Negative 4 times negative p is positive 4p. And that is greater than. Now keep in mind, I'm not flipping my symbol because when I distribute, I'm not changing anything on that side, really. It's not like I multiplied by negative 4 on both sides of the equation. That's when I'd flip it. This, I'm just distributing. I'm not adding in anything new. Okay, so now I distribute on this side. So 5 times p is 5p. 5 times 1 is 5. And now I'm going to move the p's all to that left-hand side. So I minus 5p. I minus 5p. And this is going to give me negative 12. And then 4 minus 5 is negative 1p. And that is greater than 5. Now I'm moving everything away from the p, starting with the minus 12. So I add 12 to both sides. So now I have negative 1p is greater than 17. And now I have to divide by that negative 1. And so that means that symbol is going to flip because that 1's negative. So now I have p is less than negative 17. And that's our solution, or our solution set. All numbers less than negative 17. Okay. So now we're going to talk about special cases. What happens if? All the weird stuff that happens, what do you put down for your answer, your solution? So again, I'm going to move my x's all to the left-hand side. So I'm going to minus 1x and minus 1x. And it cancels here, but it also cancels here. So remember, we're getting that double canceling thing. And now we have 5 is less than or equal to 3. And so now we have to look at the truth of the statement. Is 5 less than or equal to 3? And since it's not less than or equal to 3, the answer would be no solution. And you can also do the circle with a line through it that also stands for no solution. I like that because I have to write less that way. Okay, so on the next one, it looks like we've got some combining like terms on that left-hand side. I've got a 3x. I have a minus 1x. So 3x minus 1x becomes 2x. I then have this minus 2. That's greater than 2x minus 5. I've moved my x's to that left-hand side. And again, my x's are disappearing. So now I have negative 2 greater than negative 5. Now, if you have a problem with negatives, you really got to think about how the number line works. So here's my negative 2. Here's my negative 1. Here's my 0. So this goes negative 3, negative 4, negative 5. So is 2 bigger than negative 5? So here's my 2. Here's my negative 5. And yes, it's bigger because the bigger numbers are over here. So this is true, which means it's infinitely many solutions or just many solutions. Okay, and then our last one, we've got, combining like terms and distributive property just to keep things fresh. So we multiply in by our 2. So I have 2k minus 6 is greater than, and then over here I have got a 6 and a minus 3 that can combine. 6 minus 3 is 3. Okay. And then I'm going to move my k's all to that left-hand side, so I'm going to minus 3k from both sides. And so now I have a negative k minus 6 is greater than 3. I add 6 to both sides. So now I have negative k is greater than 9. And now I got to get rid of that negative. So this is really a negative 1k, so I divide by negative 1, which means this is going to flip. So k is less than negative 9. So I guess I just threw that in there so that way no one was guessing on if it's no solution, many solutions. It's just a regular problem. Okay. So now we're going to look at a story problem. So home cleaning company, I'm going to put home cleaning, charges $312 to power wash the siding of a house plus $12 for each window. So we have a flat fee of $312 and then $12 for each window. So I'm going to put 12W, W standing for window. Okay. Now Power Clean charges $36 per window, and the price includes power washing the siding. So $36 a window. No flat fee. We're good to go. So now I have to look at the relationship between the two. How many windows must a house have to make the total cost from the home cleaning company less than the Power Clean? So I want home cleaning less than the Power Clean. And there's our inequality. And so we're not going to really work this out because, again, we're just practicing writing these inequalities because we've practiced solving them. It's the setting up of these word problems that are tricky. And so if we just concentrate on how to set it up, we don't have to worry about the rest of it and get bogged down. Okay, so that's it for 2.5a notes. Please remember that really there's not a 2.5b notes. There's a 2.5 quiz coming up. So be prepared, study, have your notes all ready for that 2.5 quiz.